All right, and then my microphone's covered up. Okay, and then you are probably going to have to find the area under the curve, which was the very first thing we learned. And so you might have to use some geometry formulas. So this is going to be geometry areas. But I think you can get away with just knowing rectangles and triangles. If you know a trapezoid, well, we are going to need to know trapezoid for another thing that we're going to do. But if you know trapezoid, it might save you some time, but I think you guys are going to be fine on those areas. Okay, so we are going to do 2018 number 3 together, and then you guys are going to do 2014 number 3. And so remember that you are not going to be able to, like on the real test, this is going to be on a computer. You are not going to be able to write on it. So you might practice that now. It's up to you. Also, I would like for you to use a pen on the FRQ. I'm going to actually give you one before you take your test, a nice one, a Sharpie S-Gel pen. So you, at some point before you take the test, you might practice writing in ink, but the reason is because they scan your tests, and sometimes when pencil is scanned, it makes it really hard to read, but ink looks beautiful. And if you mess up, it's okay. You can just work it off somewhere else, and then mark it off, or just don't mark it off. If you mark something out, the person grading your test won't read it at all. So anyway, we'll practice some with that. So anyway, this graph is a continuous function of g, and it is the derivative of f, and it's shown above. The function g is a piecewise linear function from -5 all the way to 3, and then it is a parabola, and we have the equation for the parabola from 3 to 6. All right, so this is what I would do. As soon as I read that, g is the derivative of f, I would, in my notes, I would say that g is f prime. We're going to use that many, many times as we go through this question. All right, so if, I keep trying to scroll the wrong thing. If f of 1 equals 3, what is the value of f of -5? Now, we have done this many, many times on this review, so I feel like you can do this without me, but basically we want to find f of -5, and we know f of 1, and we're going to add an integral to it. What are going to be my limits? 1 to -5. Now, I know that's weird, but that is how we're going to write it. And then we can do this as long as what we're finding the integral of is f prime of x, and it will be, because it's going to be the graph, and the graph is f prime. Now, I personally don't really like the way that looks, and Skylar was kind of talking about this yesterday. I'm gonna go, well, let's go ahead and write what f of 1 is. F of 1 is 3. And then because the lower limit is bigger than the upper, we can change it to subtraction and then switch those. That's just gonna, for me, is gonna make it easier to do. Otherwise, you have to move backwards, and then it ends up being negative anyway, so I would recommend you change it. Now, on a calculator question, your calculator knows exactly what to do, but this is not a calculator, and we're gonna have to do some areas. All right, so we need to find the integral from -5 to 1. And so if I'm looking at this, and I can't really point at it, -5 to -2 is a rectangle. So let's go ahead and do that area first. right, and since we are going to subtract multiple things, you definitely need those brackets. And so what would be the area of that first rectangle if you multiply base times height? Say what?
4.
I think it's 3 by 3.
Oh,
Yeah, it's 9. Because it's under the x-axis, what should we write?
Negative.
-9. Good. All right. This is kind of hard for me to do on this. And then from -2 to -1, I have a triangle. And so the triangle is 1/2 base times height. So what's that going to be? Yeah. So you're welcome to write it as -1.5 or -1/3. Just kidding. Don't write it as that. -3/2. There is no preference. Do whatever you want to do. All right. And then finally, we need to go from, where do we need to go? Yeah, so this at 0, there is no area. From -1 to 0, there is no area because it's a horizontal line on the axis. And then we need to go from 0 to 1. So what's the area of that triangle? 1/2 base times 1. Does it need to be positive or negative?
Positive.
Yep. And then you're going to stop. You are not going to, it won't be hard, but it is going to waste time. We are not going to figure out what that equals because it doesn't matter in the grand scheme of things. Okay, so now let's go back to the question. Question B wants us to evaluate the integral from 1 to 6 of g of x. So write that down. So tell them what you're doing. Okay, so from 1 to 3, we can just do a geometry area. But then from 3 to 6, we're going to actually have to use like the formula, the antiderivative. So let's write that. So we're going to break it into 2 different integrals. We're going to go from 1 to 3. And that's just going to be easy geometry area. And do that, we're going to find the integral from 3 to 6. And then it tells us that g of x is equal to 2 times x minus 4 squared. Okay, so look at that for a second. Make sure that makes sense. I'm not 100% sure if you need to write that way. I think if you just went ahead and did all the things, it would be okay, but this is a good way to explain to them what you're doing, because the people grading your test don't know you, so they don't know what you know. All right, so from 1 to 3, what's that area?
4.
Yep. Okay, so to do this second integral, I'm going to take that 2 and bring it in the front. It's just going to make it easier to do. And you can do that with a constant that you're multiplying. And then I am also just going to go ahead and square x minus 4. I'm writing too big. We still have a little bit of work to do. Okay, and then go ahead and find the antiderivative of x squared minus 8x plus 16, please. And then I'm going going to try and squeeze all of this in. All right. And then at this point, we just need to plug in 6 and then minus and then plug in 3. Using parentheses would be a really good idea here. We don't have to cube any, we don't actually have to do the math, but if you don't put the parentheses, you probably won't get the point. All right, and then you can stop. Please, please, please don't take the time to do that. You really want to try and get everything done in every FRQ done in 15 minutes. I'm pretty sure your timer is built into the testing platform. Okay. And then on this one, we want to know for -5 to 6, what open intervals, if any, is the graph of f both increasing and concave up? And we're going to give a reason. So what we have is the graph of g. So just a reminder, and I probably would write it again. I would write that g is equal to f prime. My iPad is on my last nerve. Okay, so let's just talk about f and f prime because we want information about f. And so if we have the graph of f prime, when is f going to be increasing? Say it again? When it's positive. So we would say that f is increasing when f prime, which is g, I would just keep saying that, is positive. Please do not say it, because we have so many different things we're talking about right now. So make sure you're very specific. All right, the other thing was about concavity. So if we have the graph of f prime, how would we know when f is concave up? When f prime is increasing. Very good. I'm going to go back and look at the graph. So we're looking for times when the graph of g, which is f prime, is both increasing and positive. So above the x-axis and increasing. What do you guys think?
0 to 1. 4 to 6.
Perfect. All right, so then I would say something like f prime, which is g, is positive and increasing. Now they said open interval, so no matter what, if you don't even have to think, do these need to be parentheses or brackets? So they say open intervals, we 100% want to do parentheses. So on the interval from 0 to 1 and from 4 to 6. So you can write and, or you can do that whatever. Therefore, now we're going to answer the question. And we're going to answer the question with their words. So they want to know when is the graph of f both increasing and concave up. I'm going to say those words. Therefore, the graph of f is both increasing and concave up on those intervals. So give a reason for your answer. That is the reason for your answer. So just make sure you do all the things they tell you to do. All right, and then for D, we are going to find the point of inflection of F. So given the derivative, we're going to find the point of inflection, and we're going to give a reason. Do you guys remember?
G goes from positive to negative.
Not positive to negative. So positive to negative would actually be a relative maximum. Extrema, good. So if we have the graph of f prime and we want to find the point of inflection of f, it's going to be at a relative max or relative min, relative extrema, because we're going from 3 to 4, because it's f prime changes from decreasing to increasing, f changes from concave down to concave up, which is what a point of inflection is. All right, so here we go. So I would just say, answer the question, f has a point of inflection when f prime, which is g, has relative extrema. Therefore, f has a point of inflection when x equals 4. All right, what questions do you guys have? Okay, I think you're going to do good on this one. All right, so on the back of your page is the one I want you guys to practice.